Hello all, welcome to Ambari Cloud YouTube channel. Today I'll be reviewing about Snowflake Iceberg dynamic tables. Okay, intro, what are dynamic tables? And then I'm going to do a Snowflake dynamic table demo. Then how are we going to read the Snowflake dynamic table from Glue via Spark. We're going to register into Glue catalog and then execute through Spark. Snowflake dynamic tables are a way to automate data transformation within the Snowflake data cloud. We are looking at data transformation, right? Let's say you have a fact table where you are continuously inserting it, and then you want to build a summary table on it, right? So you want to have a continuous summary table. How to do that? You can do a Spark job running, or you can have a task job with the stored procedure and all that stuff. But now with the dynamic table, things are made it easy. So this is kind of a materialized view, right? And continuously getting updated based on your defined query, right? And it's simple, your group by, order by class, and then not order by, group by window functions, whatever materialization you want to do, and then summary reports, and then are multiple summary reports, different kind of summary reports on your fact table, and you continuously do it as soon as you complete your insert, update, deletes on your base table. So it's an automated pipeline, right? Instead of writing a complex script to scripts or scheduling tasks for data transformation, you define your what query you want, and then just create a dynamic table. Okay. And then behind the scene, Snowflake will handle all your pipeline execution. You want to run by minute or hour, whichever way if you want to do. You don't have to build a task and stream, all the stuff. It's a declarative approach, right? You just define the table format, and then just create it. So you don't have to do the complex steps. Then it reduces the development time, of course. Then reduces chances of errors, and then improves your productivity, and easy to modify your dynamic tables if there is a need for additional changes, right? And since these are dynamic, right, and the refresh happening continuously, and depends on your configuration, like a minute or hour, whichever, then you are seeing you don't have to execute manually, or you don't need to define separate task, stream, and all kind of stuff. It's made it easy. So the data is always up to date based on your schedule time. So reduce complexity. You don't have to write complex data transformation logic. Basically, your select statements, and simplified development because of the declarative approach. Faster, easier to maintain. That is, remember that word, easier to maintain, because you're just maintaining a select statement. And data is always refresh and reflects the latest changes. And you can use various data transformation scenarios for simple aggregation to complex joins across multiple data sources, right? Here, it's not just one simple table summarization. You can make a join with other dimension tables also. Data warehouse use case, particularly when you are doing ETL process to populate warehouse with the transform data, right? It all depends, right? You want to do everything within the Snowflake, and yeah, this is very easy approach. If you want to do raw data, then you want to do cleanse it, and then then as soon as the data inserted into raw table, then you want to do branch and gold, right? Sorry, silver and gold. Yeah, you can done through dynamic tables. So you can build a dimension modeling easily. And then, of course, since the data is You can summarize your fact tables or in any other way if you want. Then dashboards can be real time. So overall, Snowflake dynamic table offer a powerful and user friendly way. Remember that is important. I like that user friendly way to automate data transformation within the Snowflake platform. Easy to do, and then is reduce the development complexity and ensure your data is up to date. Olden days, yeah, this is a complex, but with the dynamic tables, you just write your SQL and then wrap it with not wrap it, but just create as a dynamic table your SQL, and then schedule it, and then now you can create an Iceberg table too, right? So that means your table is created in your disk, in your storage, S3 or ADLS. Then other tools like EMR Glue and then can read it. So that's what that this demo is today. So here, if you look at, this is a Snowflake permanent table still sitting on S3, but we don't have access. But now if you have a Snowflake dynamic table, right, and it is creating on your disk, right, and of course Parquet format, and then every time when you update, changes data, the data will be reflected here, and this data can read through um, you know mm, Dremio, Trinio, Cloudera, and Databricks, whichever are us, EMR, Glue, and all that stuff. Right? You can read. So now your continuous ETL process happening, and you're getting summaries. Then others can read it. Or if you want to have a base table, so others can do summarization. Then Snowflake can read. So definitely a more flexible way to build your dashboards, or ETL processing, ELT processing through dynamic tables. Okay, so how do you create a dynamic table, right? So first thing is make sure that a storage serialization policy is compatible. You need to change at the account level with admin, so that way the Parquet files can read through other tools too. Then on your base table, right, where you want to create a summarization, for example, this is my source cells, which is a fact table, and then you need to change the tracking. We do the same thing if you want to do streaming, and then do a task on it, right? Then this is my role, right? And then I'm going to create a dynamic table, right? Drop dynamic table if exists sales fact, right? So this is my sales fact table, right? And then of course this is my base permanent table, right? And then so you're going to create dynamic Iceberg table. Again, now here we are creating Iceberg table, not Snowflake dynamic table. We are creating a Snowflake dynamic Iceberg table, right? And then we're going to execute in this example every 1 minute. But again, we watch on that. This is expensive because every 1 minute your cluster need to be executed. So if you have a static cluster, which is fine, but if you have a elastic dynamic cluster, then every time when you run it, then yeah, but watch on that how often you want to, what is your lag, right? Now this is a Iceberg table, and we want the Snowflake is managing it, right? Because otherwise, you cannot update your Iceberg table. So it has to be managed by a Snowflake. This is very I tested object integration. It won't work, right? But it has to be managed by Snowflake, right? Because the Snowflake is managing this table. What does that mean? Snowflake is updating, deleting, inserting the data. But object integration, some other tool is managing and you are reading it. Okay. Then you need to define your external volume, right? So look at other YouTube channels in Ambari Cloud, how to create external volume, and how to create a normal Iceberg table in Snowflake, and how to create a Snowflake catalog, or object integration, or how to integrate with the Glue and other stuff. Then where do you want to you want to create this table? So you have already volume, which is defines your bucket root. then the location of your table. Then here, I know this is simple. Every time when I insert someone insert into this table, we want to just create a fact table which is in Iceberg. Generally, we won't do this, right? Why you want to have a permanent table converted into Iceberg table, right? However, which is also another think another way. You want to convert this table eventually into a Iceberg table, and then as the data continuously coming, and once the data is done, then your table is your source cells converted into sales fact table, which is an Iceberg table. Later, yeah, and then you convert this one into instead of dynamic, you convert into Iceberg Snowflake Iceberg catalog table. Then you can drop source this table. Okay. So you have a base table, you insert data, and you can update. You can look at the count, and then after 1 minute you will see changes. Right? Then update again, you see the changes after 1 minute because I'm running the refresh every 1 minute. Now this is where interesting, right? Here I want to create a dynamic Iceberg table, right? Again, same sales data, right? But what we are doing is it's the same thing again. It's a dynamic, but it's a sales summary, right? And the same volume, and then this is my location, and then here I'm summarizing, right, by customer and location, and we want to the total amount, by customer by location. Right, location here is state. So every time when you update, so for example, sales amount updated or inserted, deleted, and then your the customer summary will be automatically reflected. Okay, let's do the demo. Okay, so here the I'm as I said, I'm as an admin, I'm doing the serialization setup, right? And then I'm going to create my base table, which is my permanent table here, or maybe raw table. Okay, and this is my data here, right? You saw that, and Wisconsin, Illinois, different amount. Now I'm going to I change the role here, and then I'm going to drop my dynamic table if it already exists, right? But of course, production we don't do that. Then I'm going to create and my fact table, and then this is my external volume pointing to my Ambari Cloud bucket, right? And then I'm going to create a dynamic table and execute it every 1 minute, right? And then let's wait for before we do let's do a select on it on the fact table. Okay, yeah, for a sale ID called customer ID 2, right? And then this is a $3,000. Let's run an update, and then execute here. Still $3,300, but I changed to 1,500, right? And we'll wait for a minute. But meanwhile, let's go to bucket here. Okay, and then I said when I'm designing my table, my base location is prod and sales fact, and this is my bucket. Then prod, then you have my sales fact table, then you have a data and metadata. So it follows the Iceberg format. Let's go to the metadata, right? And then I have a metadata JSONs here. Then this is my snapshot. So it follows the exact the format of Iceberg. Now let's go back to here, my data directory. Then it is creating Parquet files. Now let's go back to right here and execute. Now I have a $1,500, right? And so this is how your continuously your data getting updated every time when you change. Now let's change. Let's run select star here one more time, and then let's change the sales ID equal to 2, right? Then customer ID equal to 2, right? Then I'm going to change 500. Let's say I will add 7,000, right? And run the update one more time. Okay, update successful. Then the sales ID, okay, I did the same thing again. That's fine. Yeah. So run again. Sales team still showing 1500, but supposed to show 7,000, 70,000. Wait for another. Now let's go back to our directory structure here. Right now, if you look at the every time when you do commit, it's going to create a new snapshot. Let's go to metadata. Right. So now it's creating a new JSON, and then of course new snapshot ID every updates. Right. So one thing I'm doing is still research on. If you do continuously inserting massive data, then as this number of files are keep increasing, then what you need to do is you cannot do manual compaction, but you can alter the retention time, right? Alter this table and change the retention time to 30 days or 10 days or 1 day, depends on how you want, because you don't need a time travel, right? On the summary table, if you want, you can rebuild your summary table from your fact table, right? So then watch on time retention. Then if you set the retention, alter table, set the retention equal to 3 days, 2 days, then automatically your the snapshots will be expired. Okay, now let's go to here. Okay, 70,000. Now let's do the summary table, right? And I'm going to here. Now look at the summary table, right? And then exactly same thing, but only difference is I'm just creating a summary of fact table. Okay, now let's run the summary. Okay, now customer ID by location is the summary, right? Now let's do an update on the base table. Okay, now let's run on the summary, right? And this is ID equal to 1, and so custom sales ID, customer ID 2, right? But still old number. Let's wait for the update. Let's look at the fact. How is the fact showing right now? Has been refreshed. Yeah, fact also not refreshed yet. Okay, you have to wait for a minute, right? Okay, now look at this one, the number changed. Now let's look at the summary here. Yeah, number change here, right? Because as soon as you update number. So this is how you build your dynamic tables. Okay, now what we're going to do is we're going to integrate this dynamic table to Glue. Okay, I'm going to, so here I have a method. Give me the latest metadata JSON file at a given location. Okay, so I set up my Spark session. Okay, show me my Glue. So basically it connects to the Glue here because I did my credentials, and then check databases. Okay, and then I'm going to create a prod database, and Glue here is my catalog name, my just the catalog name here. It can be any name you want. Okay, I'm going to then after that check the tables, right? And then I'm going to use a summary table, right? I'm going to create a summary table here, and then right, so I don't have it. Then so let's look at here. Sorry, here. Go to Body Cloud prod. Then look at the summary directory, right? I have a sales summary, right? Prod sales summary, and then go here and prod sales summary. Okay, metadata. Then now this is the latest metadata JSON file, and then what we're gonna do is we're gonna register into Glue. Okay, now I have a sales summary. Then from Glue, I'm going to execute my sales summary. Okay, so the same number what we see here in the Snowflake. Okay, now and then let's update a dynamic table again. Now we're going to change to, right, $30, $99, for example. Right, let's do that. Okay, and then let's check our fact table, summary table, sorry, and wait for a minute. Then it should be in the customer ID, then the sales ID, it should be $90 here, $99. After you practice your these dynamic tables, and make sure that you drop these tables. Otherwise, every 1 minute your cluster is running, and you will be end up paying a lot of money. Okay. Summary. Let's go to the summary here. Okay, $3.99 because there is another location, Illinois, then 2 rows, right? Different customer, right? So $3.99, right? Yeah, if you run, let's run the fact table, right? Customer ID 2, right? Customer ID 2, Illinois, $399, right? And now let's go to Glue. Okay, let's run Glue summary. No, it's not updated, right? So that means, yeah, Snowflake updated, but Glue is not aware of changes in Snowflake. What you have to do is you have to come back and drop the summary table again, okay, and re-register, right? And $399. So you need to refresh, right? Since we are using the reading a Snowflake table through Glue catalog. So this is how every time when you want, keep in mind, right? You're not creating a new data set. You're reading same Iceberg table, right? You're just creating a table in Glue and pointing to files which are created through Snowflake. So we are not duplicating the data. We are just reading same data. So let's prove that, right? Okay, and let's go to Glue, right? Okay, again, it is just reading the same product sales summary. So it is not recreating, duplicating the data when you read from Snowflake, from the Snowflake table. All you have to do is every time just create a simple procedure, refresh, and then drop the table, refresh it, then you will see it. So this is the advantage of having you built tables in Iceberg format. So this is how you create a dynamic table, and then register once you've done your summary tables and register it and test it, in Snowflake. Then you can register in your Iceberg. You register Iceberg table in Glue catalog, and then Spark can read it. Okay. So reach out to me any questions. Thanks for listening.